This is Casey Wilson. I'm founder of Soqucoin Labs, and this is our final demonstration for the final submission to the Colosseum Frontier Hackathon. This demonstration is for SOQ-TEC, and SOQ-TEC is short for Soqucoin Tech. We're leveraging our Soqucoin layer 1 native post-quantum blockchain technology for this. And basically the project is all about developing a quantum safe cross-chain gateway, the bridge between Solana's speed and Soqucoin's post-quantum security. So we have invented and filed 2 patents to protect this architecture. One of them is shown on the left side of the screen. It's called XMSS-Lite Revolving Vault. And this is a hash-based signature scheme that secures the bridge treasury. Traditional multisigs use ECDSA, which a quantum computer breaks or will break soon. Our vault uses XMSS one-time signatures with automatic key rotation. When the leaf set exhaust, the vault atomically rolls to a fresh Merkle tree. No human intervention, no key ceremony, and no window of vulnerability. The second patent that we have filed for this project is called Quantum Express. This is our settlement protocol itself. It coordinates atomic transfers across 2 fundamentally different chains, Solana's ED25519 and Soqucoin's Dilithium. The relayer posts collateral, executes the cross-chain swap, and the proof settles on both chains simultaneously. If either leg fails, both revert. All right, so let me show you this working live. We're going to move to our both terminal screens and our SOQ shield in the middle. So what you're looking at is our patent pending post-quantum wallet called SOQ shield in the middle. This will be the center of our demonstration. And the left side, we have SOQ-TEC terminal technology. The left side shows a recent layer 1 block activity on our StageNet, which is currently live. Left side bottom is our live transactions on StageNet. And on the right side, we have our terminal window showing, in this case, the gateway activity log on the top. And in the middle is a workflow diagram that shows you the flow and the process flow. And on the bottom, we have a live feed to the Solana DevNet. Okay, so what we're going to do for this first demonstration is to show you that we have a portfolio of our Soqucoin, our post-quantum secure USD SOQ, which is our stablecoin, native stablecoin for Soqucoin. And we also are showing the SPL token PSOQ, otherwise known as SOQ-bit. And you can see the balances for all these accounts currently. So from this point on, I'm going to show you the gateway. And this gateway screen is the heart of the gateway technology. And you can see that we have the capability to transfer between the SPL token and the native Soqucoin in both directions. We're going to go ahead and start with sending a certain amount of PSOQ, and you could either type it in or use our handy percentage buttons where you could just allocate a certain percentage of the funds. So let's go ahead and send 10%. And then while this is in process, you'll notice that the burn via the XMSS vault, CPI, and the Watts Plus leaf 3. We have 12 remaining. That's being shown on the DevNet Solana live feed. Corresponding with that is the gateway feed. And then you can see on the left side, the layer 1 for Soqucoin currently has a pending mempool. And then on our portfolio for Soku Shield, you can see that the pending transfer is currently in progress. So while that's happening, let me give you a little bit of a background on how this works. Now, we forked Solana as a Winternitz vault, solving its two biggest limitations: single-use keys and no SPL token support. And we connected it to our Halborn-audited Dilithium layer 1 via the first quantum safe attestation bridge, and added Quantum Express for high performance finality. And of course, as I explained, we have 2 patents filed for this project. And this is not just a theory, this is actually running live. So while mempool is currently pending, I'll explain to you what's happening. So what's happening under the hood, the relayer burns PSOQ on Solana. Oh, looks like the transfer is complete. So the relayer burns PSOQ on Solana, and you were able to watch that token balance drop on the Explorer. You could see here on the Explorer that has dropped. And we have what's called a chain event adapter, which detects the burn. And then we also have a dual unicast adapter that validates finality. And our signing service releases Soqucoin from the bridge vault on our layer 1. The release is signed with Dilithium, and we have no classical crypto in the path. The fee is 0.1%. So to put this into context, everyone knows that ED 25519 signature on Solana is vulnerable to what's known as HNDL, harvest now, decrypt later. So we all know that quantum adversaries are recording today's transactions and could forge those signatures when quantum computers get to the point that they're able to do it. The burn makes the Solana side exposure disposable once burned. There's no ED 25519 key left to attack. So the value migrates to our layer 1, where it's protected by Crystal's Dilithium NIST FIPS 204, the same standard that the US government mandates for post-quantum signatures by 2035. And the layer 1 release is handled by SOC Signer, and that's our dedicated Dilithium signing service. It watches for burn events via the CEA pipeline, constructs a release transaction, signs it with MLDS 44, and broadcasts via Electrum X. The entire flow, burn detection to layer 1 confirmation, completes in under 10 seconds. And that varies, of course. There's no manual intervention, no classical cryptography in the signing path. Okay, now we're going to step this demonstration up a little more. So in the gateway, you might have noticed that we have USD SOQ. If you click that button, that immediately takes us to the direct mint capability. And we're going to go ahead and demonstrate this capability now. So we have the same quick percentage options, and while we do that, give me a minute. Okay, so the real differentiator here with the direct mint capability is that USD SOQ is quantum safe. It's a quantum safe stablecoin native to our layer 1. It's not a wrap token. It's used as dedicated consensus opcodes. Opcode USD SOQ mint, burn, freeze, and rotate authority. Okay, so we're going to go ahead and send now, and then I'll explain what's happening in the background while this proceeds. Okay, so like before, we've got mempool action. We have a corresponding activity in both the gateway activity log and the Solana DevNet. Now, you'll notice that when we're on the gateway, this button actually, when I actually click USD SOQ, you can see it switches to Mint USD SOQ. So this isn't just a transfer, it's actually a cross-chain atomic mint. The PSOQ burns on Solana, and USD SOQ is minted directly on our layer 1 via the stablecoin consensus opcodes. So the supply invariant is interesting and critical. So total minted minus total burn must always equal circulating. This is enforced at the consensus level. You cannot inflate USD SOQ. It's math, and it's not trust. So what you're watching here right now is something we believe is probably the world first, a quantum safe stablecoin being minted via cross-chain bridge live and on pre-mainnet network. Our consensus level enforcement is USD SOQ is not an ERC20. It's not a smart contract token. It is a native UTXO asset type with an asset type set to 0x01. And it's enforced at the consensus layer. Every full node on the network validates USD SOQ issuance. Minting requires OP5 authority, opcodes that are hard-coded in the protocol. There is no admin key to steal, and there's no contract to exploit, no rug pull to vector. Market context. I think everyone knows that stablecoin's a huge TAM. We're talking $280 billion, and stablecoins sit on chains right now with no post-quantum plan. USDC on Ethereum ERC20 is classical signatures. USDT on Tron smart contract is also quantum exposed. USD SOQ is quantum safe custody end-to-end, and we have a patent filed for that. Okay. And while mempool is still pending, one thing I want to quickly mention is we also have privacy capability, post-quantum privacy capability. So every asset on Soqucoin supports privacy, and I'll show you that real quick. Oh, and there we go. USD SOQ, $3.42 on layer 1. And you can see USD SOQ has been, the amount has increased on the balance. Pretty impressive, pretty incredible. So, as I mentioned before, privacy, we have what's called latest bulletproof hybrid, and it is a post-quantum privacy capability. This goes beyond the scope of this demonstration, but I wanted to show you that SOQ Shield does have this capability, and it's currently being tested in StageNet. You can see that we have the capability to shield and unshield our Soqucoin. And this is quite impressive. I would venture to guess no one in the world has this capability yet. And you can see on this end screen we're able to toggle transparency between the two. So maybe I'll demonstrate that to you guys if you want to see it, if you're interested. And then before I let the privacy topic go, I will mention that what we're using is latest fold consensus activation with zero knowledge range proofs verified at the node level, and it's gated behind a BIP9 soft fork pending an audit. So we again are not aware of any layer 1 that has both running simultaneously at the stage of development, and no other chain has post-quantum privacy and post-quantum signing live at the same time. Okay, so to recap, you just watched a quantum safe wallet bridge tokens from Solana to a post-quantum layer 1, a mint of a native stablecoin via consensus opcodes, and you were able to view briefly that we do have confidential transactions currently being tested in StageNet. And this is all being done from our patent pending SOQ Shield mobile application. So for this project, we have 2 patents filed, 4 opcodes, 0 classical cryptography. This is SOQ-TEC, and it's built by Soqucoin Labs. Thanks again for your time, and we'll look forward to seeing you again. Thanks, bye.